So a square. A square is a parallelogram with 4 congruent angles and 4 congruent sides. Since every square is a parallelogram as well as a rhombus and a rectangle, it has all the properties of these quadrilaterals. So the P next to the property means a parallelogram. That's a property from a parallelogram. And a square is a type of parallelogram. REC means it's a property of a rectangle, and a square is a type of rectangle. And RHO is rhombus, and a square is a type of rhombus. Right? So a square is a parallelogram with 4 congruent angles and 4 congruent sides. That's what makes it both a parallelogram, a rectangle, and a rhombus. Right? So a square has opposite sides are parallel. That's from the parallelograms. 4 right angles, like the rectangle. 4 congruent sides, like the rhombus. Consecutive angles are supplementary, like the parallelogram. Diagonals are congruent, like the rectangle. Diagonals bisect each other, like the parallelogram. Diagonals are perpendicular, like the rhombus. And each diagonal bisects a pair of opposite angles, like the rhombus. We have a lot to write in on these notes, and they're going to help you in the next lesson, because we're going to be proving, the next series of lessons, I should say, we're going to be proving that figures on a coordinate plane are different types of quadrilaterals. So the square, I have all the properties of the parallelogram and the rectangle and the rhombus, proving that a quadrilateral is a square. So if a quadrilateral is both a rectangle and a rhombus, then it is a square. So now, I want you to add the purple to your notes here. You have to prove one. You have to prove one from each of the columns there, one from rectangle and one from rhombus, to prove a quadrilateral is a square. It's not enough to prove it has 4 right angles. Right? That's just proving it's a rectangle. You also have to prove, and it's not just enough to prove it has congruent diagonals. That's just a rectangle. So you have to prove one thing from the rectangle and one thing from the rhombus. So your choices from the rectangle, you can prove it has 4 right angles. You can prove that it is a parallelogram with 1 right angle. Right? So a parallelogram with 1 right angle has to be a rectangle, because parallelogram, both pairs of opposite sides are congruent, both pairs of opposite angles are congruent. So that means if you have one 90-degree angle, the opposite angle is 90 degrees, and consecutive angles are supplementary, so the ones next to it have to be 180 minus 90, which is also 90, making all of them 90. Right? So if you prove it's a parallelogram, then you only have to prove it has 1 right angle, or you can just prove it has 4 right angles. Or you can prove it's a parallelogram with congruent diagonals, because that's the only parallelogram with congruent diagonals is a rectangle. And a square is a type of rectangle. To prove it's a rhombus, prove it's a parallelogram with 4 congruent sides. Prove it's a parallelogram with congruent diagonals. Prove it's a parallelogram whose diagonals bisect both pairs of opposite angles. Now some of these work nicely together, right? And you'll see that when we go to prove what kind of figure each of the quadrilaterals is, right? So, but before we end this tape, it's going to be a short tape. Let's mark all of the things that are true about the parallelogram, about the square here. All right, so first of all, AB is congruent to BC, is congruent to CD, is congruent to DA. Right? All 4 sides are congruent. We can also say that angle A is congruent to angle B, is congruent to angle C, is congruent to angle D. These are 4 right angles. We also know the diagonals are bisected. So that means, let's put that is now E. So we know that, actually not only are they bisected, let me add one more thing. So the diagonals are bisected and congruent. So if you're proving that a quadrilateral is a square, that kind of goes nicely together. Prove the diagonals congruent and perpendicular. So diagonals are bisected, and they are congruent and perpendicular. All those things are true about the diagonals of a square. So that means since they're bisected, AE is congruent to EC. Since they're congruent, AE and EC are also congruent to ED, and who did we miss? EB. So all of these are congruent. Maybe I should start this one with EA so it could be like the others. It was feeling left out. I switched the ordering. Not that it makes any difference. And since the diagonals are perpendicular to one another, that means this is a right angle. Right? So angle AEB is going to be congruent to angle BEC, is going to be congruent to angle CED, is congruent to angle DEA, and they are all right angles. Right? And if you notice, not only that, we have one other thing I can mark in here. The diagonals bisect the opposite angles, so that means this angle is congruent to this angle is congruent to this angle is congruent to this angle, and this angle is congruent to this angle. Right? So those angles are all congruent to one another, and that gives us, so a square is divided into 4 congruent isosceles triangles. All those 4 triangles are congruent to one another, right? Because this is a square. I think I've included all of the most important features of the square up there. All right, so in the next podcast, we're going to solve for some missing sides and angles in a square. All right, bye for now.